Hello guys, welcome back to the Year-Start Technical channel. In the last video, we have understood why peer-to-peer connection is so difficult. Today's video will focus on how webRTC bypass NAT for peer-to-peer connections. WebRTC mainly uses a framework called ICE to carry out hole punching, which integrates Tanserver and Tanserver at the same time. So Stan allows clients to discover their public IP and the type of NAT they are behind. This information is used to establish the media connection. In most cases, a Stan server is only used during the connection setup, and once the session has been established, media will flow directly between peers. And if Stan falls, Tanserver can be used as a fallback, relaying data between two peers. Tanserver has a public IP, so they can be connected by peers, even if the peers are behind firewalls or proxies. But you need to create a connection on the Tanserver and then tell all the peer devices to send package to the server, and the Tanserver forwards the package to another peer. Obviously, this approach is very overhead intensive, so it is only used if you have no choice. So here I list out the internal IP and external IP of peer A and peer B. Next, let's start the IC hole punching process. Now A wants to make a peer-to-peer connection with B. There will be 6 steps. Step 1. Before creating a connection request to signaling server, A will go to Stan server to collect the candidate address of itself. The candidate address have 3 types, from localhost candidate to Stan reflection candidate and relay candidate. Step 2. After collecting the candidate address, A will ask signaling server to connect with B and attach the SDP containing its candidate address to the server. Step 3. After user B receives the connection request and SDP from signaling server, B also goes to Stan server to collect its own candidate address in order to allow user A to connect to itself. Step 4. After user B obtains its own candidate location, it will include this information in the SDP and reply to the signaling server, and then server will reply B's SDP to the user A. At this time, both parties have each other's candidate location. Step 5. Both parties start trying to connect using the candidate in the SDP. One thing to note here, the IC will start with the local candidate first, because if the attempt is successful, it means that both parties are behind the same NAT, so they will directly use their local candidate for the peer-to-peer connection. If the internal network fails, they will try to establish a connection using the external IP location, which reflects from the Stan server. If one of them is successful, then a peer-to-peer connection will be started, and they can start sending each other videos and audios. But if local candidates and Stan reflection candidate fail, then you have to choose the backup option, which is use the Tanserver to make a relay connection. But this is not really a peer-to-peer connection. A Tanserver is usually required because one of the two peers is using symmetric NAT. The main problem is that the path for this symmetric NAT will change, and peer-to-peer connection requires a fixed path, so we need to get Tanserver involved. So today we have talked about the IC framework, and in the next video we will talk about the JavaScript APIs in the webRTC. If you enjoy our video or you can learn something from this, don't forget to subscribe to our channel, and I will see you in the next one.